Hello class, today we're going to talk about lesson 11.1 on geometric sequences. Our objectives today are we can recognize and extend a geometric sequences, and we can find the nth term of a geometric sequence. So our vocabulary alert for today. We have geometric sequence, which is just a sequence where the ratio from term to term is the same number. And then the common ratio, which is the number that we use to multiply one term in a geometric sequence to get to the next term, which we call r. So let's look at our first example, where we need to extend a geometric sequence. We need to find the next three terms in each geometric sequence. We have the sequence that starts at 1, and then the next term is 3, followed by a 9, and a 27, and that keeps going forever and ever. So our first step is to find the value of r by dividing each term by the one before it. What that means is we need to go backwards from 27 to 9. What do we have to divide by? Well, to get from 27 to 9, we have to divide by 3. Then from 9 to 3, we also have to divide by 3. And then from 3 to 1, again, we have to divide by 3. So, let's move on to step 2. Since moving backwards we divided by 3, in order to move forward we're going to multiply by 3 to find our next three terms. So we're going to start with 27 and multiply it by 3. 27, we need to multiply that by 3. Well, 27 times 3 is 81. Now to find the next term we have to multiply by 3 again. 81 times 3 is 243. Well, we have to do that one more time because we were asked to find the next three terms. So multiply 243 by 3 and we're going to get 729. So our next three terms are just 81, 243, and 729. We have finished example 1a. Let's try another example. So we have the sequence that starts with -16, and then goes to 4, and then to -1, and then to 1/4, and that pattern keeps going forever and ever. So our first step is to find the value of r by dividing each term by the one before it. So we're going to go 1/4 to -1. We're going to go 1/4, and we're going to divide that by -1, which is just -1/4. Then we're going to go -1, -1, and divide it by 4. We've got a fraction that's simplified. We need to also do that with our last one. We've got 4 divided by -16, which can simplify to -1/4. So we have found the common ratio, which is -1/4. We're going to use that to find the next three terms for step 2. So we're going to take the 1/4 that the sequence we were given ends with and multiply that by -1/4. And that's going to give us -1/16. And we're going to take that and multiply it by another -1/4, which will give us 1/64. And we need to do that one more time. Multiply by -1/4. So we can result in our third term, -1/256. So our next three terms are just -1/16, 1/64, and -1/256. We've found the next three terms. We have finished example 1. So just like in our arithmetic sequences lesson, we use the variable a to denote a term. So just a little review from yesterday. If we have a sub 9, that means we're looking at the 9th term. If we're looking at a sub 1, that's the first term. A sub n means that we're looking at the nth term. This is going to be very handy in our next couple examples. So just like for an arithmetic sequence, there is a formula for finding the nth term of a geometric sequence. It is a sub n is equal to the first term times the common ratio, and that common ratio is raised to the power of n minus 1. So let's look at an example of how we're going to use that formula to find the nth term. So the first term of a geometric sequence is 128, and the common ratio is 0.5. We need to find the 10th term of the sequence. So there's a few things we need to know. First, we need to know that the formula is always going to be the same. A sub n is equal to the first term, a sub 1, times the common ratio raised to the power n minus 1. We know some things. We know that the first term is 128. We know the common ratio is 0.5. And we are looking for the 10th term. So n is 10. So we're looking for a sub 10, which would equal 128 times 0.5 raised to the 10 minus 1, or 128 times 0.5 to the power of 9. Now we're going to simplify the exponent, 0.5 to the 9th. And 0.5 to the 9th, let's not round it. That's going to be 0.001953125. And now we can multiply 128 by that decimal value, which will give us 0.25. We don't want to round until the end, and because 0.25 is a nice number, our 10th term is 0.25. So let's look at another example. We have a geometric sequence where the first term is 8, the common ratio is 3, and we're looking for the 5th term. So again, we need to know that the formula is a sub n is equal to the first term times the common ratio raised to the n minus 1. We know that the first term is equal to 8, and the common ratio is equal to 3. We're looking for the 5th term, so n is equal to 5. So we're looking for a sub 5 is equal to 8 times 3 to the 5 minus 1, or 8 times 3 to the 4th power. Now let's do the exponent, 3 to the 4th. 3 to the 4th is 81, so we have 8 times 81. Now we can do the multiplication. 8 times 81 is 648. So our 5th term is 648. All right, let's try one more example to just make sure we have this down pat. All right, so we're looking for the 13th term of a geometric sequence which starts with 8, is followed by 16, negative 16, excuse me, and then 32, then negative 64, and that pattern keeps going on forever. So we do need to know the formula. Again, the formula is a sub n is equal to the first term times the common ratio to the power of n minus 1. We know the first term. The first term is the first number in the sequence, which is 8. We don't quite know r yet, so we'll save that for a little bit later after we identify n. We do know we're looking for the 13th term, so n is 13. So now let's try to figure out what r is. We're going to set up our sequence 8, negative 16, 32, and negative 64, and we're going to divide each term by the term before it. So we're going to go negative 64 over 32, which is just negative 2. We're going to go 32 over negative 16, which again is just negative 2. And then we're going to go negative 16 divided by 8, which is again negative 2. So r, we can safely say, is negative 2. Now that we know the first term, the common ratio, and the value for n, we can plug all of those values into our formula. So we're looking for a sub 13 is equal to 8 times negative 2 to the power of 13 minus 1, or 8 times negative 2 to the power of 12. Now we're going to do negative 2 to the power of 12, which is 4,096. So we've got 8 times 4,096. And now we can multiply 8 times 4,096, which is 32,768. So the 13th term of this sequence is 32,768. We're going to move on to our final example. All right, we have a sports application. We have a bungee jumper jumps from a bridge, and the diagram to our right shows the bungee jumper's height above the ground at the top of each bounce. The heights form a geometric sequence. We need to find what is the bungee jumper's height at the top of the 5th bounce. So we can list the first 3 bounces as our first 3 terms. So our sequence starts off at 200 and then goes to 80 and then to 32. And that pattern is going to keep going forever and ever. So we need to know first our formula. Our formula for a geometric sequence is a sub n is equal to the first term times the common ratio to the power n minus 1. Now we need to identify some important information that we know. We know that the first term is equal to 200 because that's the height of the first bounce. We don't know our common ratio yet, so we'll come back to find out what r is equal to. But we know that n is 5 because we are looking for the 5th bounce. So now let's try to figure out what our common ratio is. We have to divide each term by the term before it. So we need to go 32 divided by 80. If we simplify 32 over 80 with the calculator, that's going to just be 0.4. Now we're also going to do 80 divided by 20. And again, if we simplify this on our calculators, in fact 80 divided by 200, if we simplify this on our calculators, we'll find out again that it is 0.4. So our common ratio, we can safely say, is 0.4. Now we're going to plug each of those numbers, a sub 1, r, and n, into our formula. So we're looking for a sub 5 is equal to 200 times 0.4 to the 5 minus 1, or 200 times 0.4 to the fourth power. Now we're going to check out what 0.4 to the fourth power is. 0.4 to the fourth power gives us 0.0256, and now we can multiply that with 200 to find out the height of our fifth bounce. If we multiply that by 200, we'll get 5.12, and we have to label that feet. So after the fifth bounce, our bungee jumper's height will be 5.12 feet. That wraps up our lesson on 11.1 geometric sequences. For the rest of your homework, I would like you to complete the Your Turn problems, and I will see you in class tomorrow. Have a good evening.